Hello everyone, welcome back. In today's video, we are going to talk something deeper about three essential concepts in operating system. The first one, Peterson solution, then semaphore, and the test and set operations. So by the end of this video, you will understand how Peterson solution helps manage mutual exclusion, what semaphores are, and how they work, then, how the test and set operation works in process synchronization. But before moving further, we should know what is process synchronization. So, when a multiple processes needs to access shared resources, synchronization prevents data inconsistency and risk conditions. The key synchronization tools are Peterson solution, Semaphore, and test and set, which we are going to learn in this lecture. But if you want to learn about more about process synchronization, you can refer to our previous lectures. Moving further, what is a Peterson solution? So, Peterson solution is an elegant software solution for mutual exclusion between two processes. Peterson's solution solved the critical section problem by using two shared variables, a flag to indicate whether a process wants to enter the critical section, a turn variable to indicate whose turn it is to access the critical section. So how it works? When a process wants to enter the critical section, it sets its flag to true and gives the turn to the other process. If the other process also tries to enter, it checks the flag of the first process. The flag is set to true and it's not its turn. The second process waits until its turn. But once the process exits the critical section, it resets its flag to false. Now, an example. Imagine two people are sharing a bathroom. One person enters and locks the door. It means that he has set a flag. Then the coming person will wait until that bathroom is free. So that is decided by the turn variable. So who can enter or not. But why it is effective firstly? So first one, it guarantees mutual exclusion without needing any hardware support. It is a simple solution for two processes, but more processes would require more complex mechanisms. Moving further, we will see what is a semaphore or what are semaphores. So, semaphores are more general synchronization tool than the Peterson solution. In modern operating system, it is used to control access to shared resources. A semaphore is a counter. A semaphore is a counter used to manage concurrent processes. It can be used for two main purposes. Counting semaphore, it is used when you have a fixed number of resources. And then binary semaphore. So binary semaphore is also known as mutex or mutual exclusion. And they are also used for mutual exclusion. Yeah, ensuring only one process enters a critical section at a time. So what are the operations on semaphore that we can perform? So there are two operations. First one is wait, P or down operation. As the name suggests, it decreases the value of the semaphore. If the semaphore value is greater than 0, the process can continue. But if the value is 0, the process will wait. And then we have the signal operation. Signal operation, it's the opposite of wait operation. It increases the value of the semaphore. If there are processes waiting, one of them will be unblocked. Example, imagine a parking lot with limited spaces. The semaphore represents the number of empty seats in that parking lot. A car that is a process will try to enter. It does a wait operation which decreases the semaphore. And when the car leaves, it signals operation which increases the semaphore, allowing another car to park. That is the how semaphore works. So there are different types of semaphore also, like binary semaphore. In binary semaphore, car only have two values, 0 or 1, used for mutual exclusion. Like in computer system, that it uses only binary numbers, that is 0 or 1, 1 or 0. Then we have counting semaphore. Counting semaphore can take any non-negative value, useful for managing multiple sources like printer or any buffer. Non-negative integer means that it can also take -1, -2, +1 or anything that you can imagine, even 0 or 1. So, and now let us look at the test and set operation. It is a low level atomic operation which is used to implement synchronization mechanism like locks. So, what is test and set? The test and set operation allows a process to test a value and set it in a single atomic step. It checks a variable's value, and if it is false, it sets it to true. If it's already true, the process waits. So how it works? So firstly, the test and set operations reads a variable, usually called a lock, to see if it is already set. If the value is false, it sets the variable to true and proceed. If the value is true, the process waits for the lock to become false again. For example, imagine a bathroom lock. If the lock is false, that is, the bathroom is free, the person will enter and sets it to be true that the bathroom is occupied. Now, if the lock is true that the bathroom is occupied, the person await until it is free. This was the basic concept, but why it is useful? So the test and set operation ensures atomicity. Atomicity means it's done as a single uninterruptible step. This also helps prevent any race condition which can occur when multiple processes try to access the same resource simultaneously. Coming to the conclusion, let us quickly recap what we learned today. Firstly, the Peterson solution, which uses flags and a turn variable to ensure mutual exclusion between two processes. Then we learned about semaphores. Semaphores are counters that help manage access to resources, supporting operations like wait and signal to synchronize any process. Then the test and set operation. It is an atomic operation that helps implement synchronization by checking and setting a variable in a single step. Then we have these synchronization tools are crucial for managing the concurrent process and ensures that the system has maintained its integrity. So, if you found this video helpful, hit that like and subscribe button and comment below if you have any questions. Thank you. See you in the next video.